Okay, everybody, today we're going to start with a recap of static electricity, and then we're going to get into current electricity for the first time. So static electricity refers to the buildup of a charge in an object through it gaining or losing electrons. Remember, it's important. It's always electrons, right? And, excuse me, when the charge finds a way of equalizing, so for example, a negative object sending all of its electrons into something else, a static discharge will occur. This is like when you shock your finger on a doorknob or like on your cat or something. And it's actually what happens with lightning as well. So enough electrons or enough of a difference in charge will build up in clouds. And if the clouds are very, very different in charge compared to the Earth or other clouds, lightning will arc from one cloud to another or from a cloud to the Earth. Current electricity is a similar idea because it still uses electrons. We're still talking about electrons and a charge, but this time we're actually moving in a circuit or in through a conductor, basically. So current electricity is when electrons are allowed to flow through a material. Current electricity is responsible for nearly everything we would call an electronic or like a tool that uses electricity. Everything that uses electricity, we're basically using current electricity for. And understanding currents, circuits, and how electrons behave allow us to manipulate those things. So we're going to go into current electricity for the remainder of the unit. And today we're going to talk about specifically defining current, and we're going to do this mathematically. So current can be defined mathematically as charge per unit of time. So charge is Q, time is T. The T should be familiar, and our current is I. I know they're kind of not intuitive symbols. I personally write these down all the time because I always forget my symbols in physics. So your current is I, your charge is Q, and your time is T. So your current is equal to your charge divided by your time. And it's important to realize that your charge is, well, the way I think about it is like how many electrons are moving through, basically. Um, so current is measured in amperes or amps, you've probably heard them called. We'll use A for that. Charge is measured in coulombs, and time is measured in seconds. Again, this is something that I write down, if I'm taking a test, I write down my triangle, and I write down what everything stands for, and I write down the units for everything because I often forget coulombs because I never use it. So we're basically just going to practice using this formula for a couple word examples. Let's see if we can switch over here. Okay. So our first example says if 150 coulombs of charge pass through a point. Sorry for the grammar. Oh, let me plug in my tablet here. Okay, we're in business. So if 150 coulombs of charge pass a point in a conductor in 3 seconds, what is the current through that point in the conductor? So we're saying this is say we got our battery here. If we got our battery and our current is going this way, and we measure it at this point, and it reads 150 coulombs in 3 seconds. So remember, if we pop back to our triangle, we have Q over IT. So let's put that up here. This will be a useful tool for us. If you don't remember how to use one of these triangles, don't sweat it. We'll go over it again. So Q, I, and T. Remember, Q equals our charge. I equals our current. And T equals our time. So we know that our charge measured in coulombs is our Q, right? And this is our formula that we can plug it into. So we're looking for I. It means Q is over T. So I equals Q over T. We know 150 is our charge that we're going to put up here. And our time is 3 seconds. So we would end up getting 50 coulomb seconds, or the unit that we want to use for this, right, is amperes, which is just the same thing as coulombs per second. So we would say our current is 50 amps for this question. So let's try a different one here. We're going to change it up. We'll stick with having our, oh, excuse me. We'll stick with having our little formula here. I, Q, and T. Excuse me. And this question says, if 240 coulombs of charge, so as I'm working through this, right, I would put, okay, our charge, Q, equals 240. Pass a point in a conductor in 5 minutes, so our time equals 5 minutes. What is the current through that point in the conductor? So this, at first, looks like the exact same question, where we're just going to be plugging it into I equals Q over T, right? The kicker, though, is that this is given in minutes. So we don't want to use this because amps equals coulombs per second. So we need to convert what we've got into seconds. So always be careful of that. If you're given a different time, you need to convert it into seconds if we want to give our answer in amps. So all we would have to do for 5 minutes, we know it's 60 seconds per minute, so we would just go 5 times 60, and we end up getting 300 seconds. So that's the time that we're going to use. Okay, so let's rewrite it as into our formula. So we get 240 over 300. And if you plug that into your calculator, you should get, oh, excuse me, I equals 0.8 amps. So our current is 0.8 amps through that point. Let's try a second or a third one here. Always put your formula or your triangle. How quickly would 600 coulombs of charge, so we know our charge, need to pass through a wire for its charge to measure 14 amps? And now we're actually given something a little different. So I equals 14 amps. So we're looking for time now, right? That's our unknown. So usually our formula looks like this. Oh, and sorry, we're given this one, so we can. And if you guys remember your algebra, I hope you do, we will take this t and we need to get it up on top for it to be easier to solve by. So what we're going to do using algebra is just multiply both sides by t. So we end up getting 14t equals, and then these guys cancel out, right? 600. And then we divide that by 14. And we got to do that to both sides. So t equals 600 divided by 14, because these things cancel out. And we end up being left with 600 divided by 14. 42 point, and we'll just round up, 42.9 seconds. So that would be our answer for this question. So for this unit or for these types of questions, you guys will need to be comfortable switching around your three-piece formula. And we'll do one more where we solve for current now instead. So I equals Q over T. So in 2 minutes, okay, we got time already. 2 minutes, time equals 2 minutes, which we can actually convert right now if we want, which is, oops, 120 seconds. The current of a conductor is measured to be 1.6. So I equals 1.6 amps. How much charge is passed through the conductor in that time? So Q, we don't know. So we're going to need to change up our formula again to solve for Q. This time it's a little bit easier. We can multiply just the T out. So we get I times T equals Q. And then we can just plug everything in. So we have 120 for our time. We have 1.6 for our current. And multiplying those together should give us our charge. So 1.6 times 120. And we end up getting Q equal to 192 coulombs. Okay. So hopefully those examples make sense to you guys. If you have any questions about this stuff, let me know. And, have a good rest of the day. Cheers.